September 24th, 2025, 14:23 UTC. Solar Storm Forecast Center, Boulder, Colorado. The alert comes through as a NOAA warning. Coronal mass ejection, traveling at 1,200 kilometers per second, heading directly toward an interstellar visitor racing through our solar system at 137,000 miles per hour. For the first time in human history, astronomers will watch a solar storm collide with an object from beyond our solar system. The target? 3I Atlas, a comet-shaped mystery, possibly 7 billion years old, carrying chemical signatures never seen before. Already controversial, already defying expectations, already splitting the scientific community into camps convinced they're looking at either the most extraordinary natural object ever discovered or the first confirmed glimpse of alien technology. Now the sun itself is about to test it. In 2007, NASA's Stereo spacecraft watched as a coronal mass ejection struck Comet Encke head-on. The plasma wave, traveling at over 1 million miles per hour, ripped the comet's 8 million mile-long tail completely away from its nucleus. Magnetic fields twisted. Ionized gas scattered into the void. Within minutes, Encke regrew its tail as if nothing had happened. Resilience, natural physics, the universe behaving exactly as models predicted. But 3I Atlas is not from our solar system, and when the solar storm hits, something will begin that no one can fully explain. Part 1. The Visitor from 7 billion years ago. The story doesn't begin on September 24th, 2025. It begins somewhere in the darkness between stars. Perhaps 7 billion years ago, 3 billion years before Earth formed, in a protoplanetary disk orbiting a star whose name we will never know. Ice and rock coalesced under alien gravity. Carbon dioxide froze in concentrations 8 times higher than water. Nickel separated from iron through processes that human metallurgy requires industrial refineries to achieve. Something, gravitational kick from a passing star, planetary migration, stellar death, ejected this object into the void. It drifted, silent, frozen, crossing distances that make the mind recoil. The Milky Way rotated. Stars were born and died. Earth's solar system condensed from nebular dust. Dinosaurs evolved, ruled, and went extinct. Humans built civilizations and developed telescopes. And through it all, this object was traveling toward us. On July 1st, 2025, at 4:47 UTC, the Atlas telescope in Chile's Atacama Desert flagged an anomaly. A point of light moving wrong, too fast. Coming from the wrong direction, aligned almost perfectly with the galactic center, camouflaged against millions of background stars. Amateur astronomer Sam Dean, reviewing data weeks later, would realize that 3I Atlas had been present in images since June 14th. Professionals had missed it because it appeared in the one place perfectly designed to hide it. The Minor Planet Center designated it 3I, the third confirmed interstellar interloper after Oumuamua in 2017 and 2I/Borisov in 2019. Initial calculations suggested nothing extraordinary. Another comet. Another cosmic snowball making a brief pass through our neighborhood before continuing its eternal journey. Researchers prepared standard observation campaigns. They expected confirmation that interstellar visitors were fundamentally unremarkable. Then came the first Hubble Space Telescope images on July 21st, 2025. The images showed a teardrop-shaped cocoon of dust. Normal enough. But they also revealed something bizarre, a pronounced sunward anti-tail with a 10-to-1 elongation in 3 dimensions. Comets have tails that point away from the sun, pushed by solar radiation and the solar wind. They don't have prominent structures pointing toward the sun, unless something was thrusting in the wrong direction, or unless the dust dynamics were completely unlike anything seen in solar system comets. On August 6, 2025, the James Webb Space Telescope made its first observations. The spectroscopic data revealed carbon dioxide concentrations 8 times higher than water, the exact opposite of solar system comets. It showed nickel tetracarbonyl emissions. On Earth, nickel tetracarbonyl appears in industrial metal refining, where nickel must be deliberately separated from iron through controlled chemical processes. Nature almost never separates nickel from iron. They form together in stellar nucleosynthesis. They remain together through cosmic history. 3I Atlas was emitting only nickel. Harvard astrophysicist Avi Loeb began documenting anomalies. By his calculation, at least 7 distinct features defied comfortable natural explanation. The trajectory aligned to within 5 degrees of the ecliptic plane, where Earth and other planets orbit, with a probability of 0.2%. It would make close approaches to Mars, Venus, and Jupiter with combined probability of 0.005%. It would reach perihelion on October 29, 2025, when Earth would be on the opposite side of the Sun, perfectly positioned to make terrestrial observations difficult. Most troubling, observations between May 15 and September 23, 2025, showed no measurable non-gravitational acceleration. This is strange, very strange. Comets outgas as they approach the Sun. Volatile ices, carbon dioxide, carbon monoxide, water, sublimate into gas. This creates thrust. Small, imperceptible to the naked eye, but measurable with precision instruments. It's called the rocket effect. Every active comet shows it. 3I Atlas showed no rocket effect despite massive outgassing visible in telescopic images. The only explanation? The object must be far more massive than its brightness suggested. A team led by Richard Cloet, Loeb, and Peter Veris analyzed 4,022 observations from 227 observatories worldwide. Their conclusion, published in late September, 3I Atlas must weigh at least 33 billion tons. Its nucleus must be at least 5 kilometers in diameter. This made it roughly 1,000 times more massive than 2I/Borisov and 1,000,000 times larger than Oumuamua. The statistical problem was immediate and uncomfortable. The interstellar mass reservoir of rocky material should produce far more small objects than large ones. Basic physics. Before discovering one 5-kilometer interstellar object, humanity should have detected approximately 100,000 objects on the 0.1-kilometer scale of Oumuamua. We had detected exactly 2 previous interstellar objects. Something about the numbers didn't work. Loeb proposed a probability of 30 to 40% that 3I Atlas did not have a fully natural origin. He called it the Trojan Horse scenario, a technological object masquerading as a natural comet, hiding in plain sight while approaching the inner solar system, potentially preparing to release smaller probes during its close approach to the Sun. The scientific community's response was swift and brutal. Chris Lintott from Oxford called it nonsense on stilts. Stephen Desch from Arizona State accused Loeb of bypassing peer review to feed conspiracy theories. Jason Wright at Penn State documented what he considered fundamental errors in Loeb's analysis. NASA's Tom Statler tried diplomacy. Yes, 3I Atlas had interesting properties, but it fundamentally behaves like a comet. The evidence, overwhelmingly, pointed to a natural origin. The battle lines were drawn, and then the Sun intervened. Part 2. When Stars Attack. Coronal mass ejections are among the most violent phenomena in our solar system. They begin deep within the Sun's interior, where magnetic field lines twist under immense pressure and heat. When these field lines reconnect explosively, they launch billions of tons of magnetized plasma into space at speeds exceeding 1,000,000 miles per hour. These eruptions carry magnetic fields capable of disrupting Earth's power grids, disabling satellites, and creating auroras visible at equatorial latitudes. They are, fundamentally, the Sun flexing its power. On September 24, 2025, solar activity monitors detected a significant CME heading directly toward the orbital path of 3I Atlas. The timing was remarkable. The interstellar visitor was just 5 days from slipping into solar conjunction, the period when it would pass behind the Sun from Earth's perspective, becoming temporarily unobservable. Astronomers would have exactly 1 week to watch the collision and document the results before 3I Atlas disappeared from view until late November. The excitement in the astronomical community was palpable. Interactions between comets and solar storms had been observed before, but always with objects native to our solar system. Comet Encke's 2007 encounter with a CME provided the benchmark. NASA's Stereo spacecraft had captured the entire event. The wave of solar material approaching, the moment of impact, the comet's tail brightening intensely, and then, spectacularly, the complete disconnection of the tail from the nucleus. Magnetic fields embedded in the solar wind had literally ripped the ionized gas away from the comet's core. but Enki had regrown its tail within minutes, demonstrating that the underlying physics remained stable. The comet's nucleus continued outgassing. New material replaced what had been lost. The comet survived essentially unchanged. For 3I Atlas, predictions varied wildly. Some astronomers expected a similar tail disconnection event. The magnetic fields in the CME would disrupt the comet's coma, twist its tail, perhaps separate ionized gas from the nucleus. Then, like Enki, 3I Atlas would recover and continue on its trajectory. A spectacular light show, but ultimately routine. Others were less certain. Angelos Vorlidas from the Naval Research Lab noted that the 2007 CME that hit Enki had been relatively slow, barely creating a pressure pulse. Any CME striking 3I Atlas closer to the Sun, where it was headed, would likely be faster, driving a shock wave with a much stronger magnetic field. The effects could be far more dramatic. And then there was the uncomfortable possibility that nobody wanted to say aloud. What if 3I Atlas wasn't a comet? What if Loeb's Trojan Horse scenario had merit? A technological object encountering a solar storm wouldn't respond like a natural comet. It might deploy shielding, it might alter course, it might absorb energy in ways that violated expected physics. The CME would become, inadvertently, the ultimate test of 3I Atlas's true nature. Amateur astronomer Worachet Boonplod positioned his equipment. Professional observatories worldwide coordinated schedules. NASA's Solar Dynamics Observatory and the Solar and Heliospheric Observatory turned their instruments toward the predicted collision zone. Everyone waited. Part 3. The collision. The CME arrived on schedule, September 24th to 25th, 2025. A wave of magnetized plasma traveling at over 1,200 kilometers per second slammed into the coma of 3I Atlas. Instruments recorded the impact. The comet's brightness surged, particularly in the green part of the visible spectrum, diatomic carbon, C2 molecules being energized by sudden electromagnetic bombardment, glowing emerald as UV radiation tore through their molecular bonds. The tail should have disconnected. That was the expected result based on Enki's 2007 encounter and every other comet CME interaction ever observed. It didn't. Instead, something strange began happening to the tail structure. The anti-tail, the sunward-pointing jet of particles that had puzzled astronomers since July, started changing. Images from the Nordic Optical Telescope in Spain's Canary Islands showed the anti-tail diminishing while a new tail structure grew in the direction away from the Sun. Not a disconnection, a transformation. By late September, the anti-tail had essentially disappeared, replaced by a more conventional tail streaming behind the nucleus. Astronomers David Jewett and Jane Liu analyzed the data and concluded that the mass loss rate from 3I Atlas scaled roughly with solar radiation flux, exactly what you'd expect from carbon dioxide sublimation driving comet activity. Natural behavior, physics working as predicted, except for one detail nobody could explain. The comet hadn't just survived the solar storm, it had absorbed it. The expected disruption, twisted magnetic fields, scattered ionized gas, temporary chaos in the coma, never fully materialized. Instead, 3I Atlas seemed to ingest the energy, restructure its outgassing patterns, and continue forward. The transformation from anti-tail to normal tail occurred smoothly, without the violent disconnection events that characterized every previous comet CME interaction on record. Avi Loeb and Eric Kito published a theoretical model explaining the transition. They proposed that the anti-tail had been dominated by sunlight scattering off water ice fragments ejected by carbon dioxide sublimation. The CME's energy altered the sublimation dynamics, changing the ejection angles and velocities of these ice fragments, causing the visible transformation from anti-tail to tail. Plausible, well-reasoned, supported by mathematical modeling, but it required unprecedented sublimation physics. Ice fragment sizes and ejection velocities that existed at the extreme edge of what comet theory allowed. The model worked, but it worked by pushing every parameter to its limit. And then came the acceleration. Part 4. The acceleration. Nobody expected for months, 3I Atlas had shown no measurable non-gravitational acceleration. This was the primary evidence that it must be anomalously massive, at least 33 billion tons. Objects that massive don't get pushed around by rocket effects. Their tremendous inertia resists change. The outgassing that creates visible tails produces negligible acceleration on such large nuclei. After the CME collision, that changed. Observations from the Keck Observatory in Hawaii and Gemini South Observatory in Chile documented something unexpected: subtle but measurable deviations from the gravity-only trajectory. The comet wasn't following Newton's laws as precisely as before. Something was applying force. The magnitude was small, fractions of what typical comets exhibit, but it was real, and it appeared after the solar storm encounter. Two possibilities emerged. First, the CME's energy had triggered increased outgassing from regions of the nucleus previously dormant. Solar system comets sometimes exhibited this behavior when sudden heating activated new vents or caused subsurface ice to fracture and release volatiles. The new outgassing created asymmetric thrust, pushing the comet slightly off its predicted path. Unusual, but explicable within comet science. Second, the CME had triggered something technological. If 3I Atlas was indeed a probe or mothership, the solar storm's electromagnetic pulse might have activated systems, charging batteries, initiating maneuvers, or deploying equipment. The acceleration might represent the beginning of controlled flight. Loeb emphasized caution but noted the implications. He wrote, "Post-perihelion observations at Earth's closest approach on December 19, 2025, will provide the most important clues about its nature. If, as a result of intense solar heating, 3I Atlas shows all the features of a natural comet, I will reduce its rank to 2 on the Loeb scale. Not to 0, never to 0. Because the enormous mass relative to previous interstellar objects and the orbital alignment with the ecliptic plane would never go away. These weren't anomalies that could be explained away. They remained statistical outliers regardless of how natural the comet appeared." But Tom Statler at NASA pushed back firmly. "It looks like a comet. It does comet things. The evidence overwhelmingly points to a natural origin." He emphasized that every unusual feature had potential natural explanations. Rare didn't mean impossible. Unlikely didn't mean artificial. The scientific debate continued, but the object itself was about to enter the most critical phase of its journey. Part 5. Into the Fire. October 29, 2025. Perihelion. The moment when 3I Atlas would pass closest to the Sun, 1.36 astronomical units, roughly 203 million kilometers, between the orbits of Earth and Mars. Closer than Earth. Not as close as Mercury, but close enough to experience intense solar heating. At least 33 gigawatts of solar radiation would bombard the nucleus. For a natural comet, this is the defining moment. The intense heat vaporizes volatile ices buried beneath the surface. Structural weaknesses, fractures, voids, poorly cemented regions experience thermal stress. Some comets brighten spectacularly, others fragment catastrophically. Comet 2I/Borisov, the previous interstellar visitor, had fragmented during its perihelion passage in 2020. Studies suggested comets might form from smaller pieces that gently coalesced over billions of years, creating poorly cemented structures riddled with internal fractures. When solar heating penetrated these weak points, the entire nucleus could break apart. Would 3I Atlas fragment? If it was a natural comet, especially one 7 billion years old, subjected to eons of micrometeorite bombardment and thermal cycling, structural integrity was questionable. Perihelion might be its death. If it was technological, if Loeb's Trojan Horse scenario had any validity, perihelion would be the optimal moment for maneuvers. The Oberth effect. Spacecraft firing engines at the point of closest approach to a massive object achieve maximum change in velocity. Fuel efficiency peaks at perihelion. A mothership releasing mini-probes would do it here, now. But there was a problem. A critical problem that made October 29th even more significant. From Earth's perspective, 3I Atlas would be positioned directly behind the Sun. Solar conjunction, completely unobservable from terrestrial telescopes. The geometry of Earth's orbit, the Sun's position, and 3I Atlas's trajectory created a perfect eclipse. The object would be hidden behind the Sun's glare from late September through November. If something happened at perihelion, fragmentation, maneuvers, probe deployment, Earth-based observers would miss it. This alignment had a probability of roughly 7% for a random trajectory. For 3I Atlas, it was exact. Loeb had noted this in multiple papers. If you wanted to conduct operations while minimizing Earth-based observation, this geometry was perfect. A clandestine reverse solar Oberth maneuver, using high thrust at perihelion to break and remain bound to the solar system, could be executed with complete obscuration from humanity's primary observation point. Coincidence or design? The only spacecraft positioned to observe 3I Atlas during perihelion were space-based assets: NASA's Parker Solar Probe, ESA's Solar and Heliospheric Observatory, SOHO, and the GOES-19 satellite's CCOR-1 coronagraph. These instruments weren't optimized for cometary observation. They studied the sun, but they might catch glimpses of 3I Atlas as it passed through the inner solar system. On October 21st, amateur astronomer Warachet Boonplod processed data from the CCOR-1 coronagraph. He confirmed that 3I Atlas was visible in the images, showing a gas and dust coma and, remarkably, still displaying a faint anti-tail even as the object approached perihelion. The comet was surviving, intact, active. But what would happen in the next 8 days when solar radiation peaked and the object experienced maximum thermal stress remained unknown. Part 6. The government shutdown. On October 1st, 2025, the United States government entered a shutdown. Federal agencies halted operations. NASA's Mars missions stopped releasing data. The Mars Reconnaissance Orbiter, which had captured the highest resolution images of 3I Atlas during its close approach to Mars on October 3rd, went silent. The high-rise camera had achieved a pixel resolution of 30 kilometers, providing the most detailed view of the object's surface structure ever obtained. Those images remained unreleased. The timing could not have been worse, or, depending on perspective, more suspicious. On October 3rd, 3I Atlas had passed within 28 million kilometers of Mars, 0.19 astronomical units. Multiple spacecraft observed the flyby: Perseverance rover, Mars Express, ExoMars Trace Gas Orbiter, and crucially, Mars Reconnaissance Orbiter's high-rise camera. The images showed something genuinely unusual: a rounded central structure unlike the irregular potato-shaped nuclei typical of comets. Online, observers claimed it looked artificial, geometric, structured. Then the government shutdown killed all data flow. Conspiracy theories flourished in the information vacuum. NASA was hiding evidence of alien technology. The government shutdown was a cover for emergency planetary defense preparations. The truth about 3I Atlas was being deliberately suppressed. Loeb publicly criticized the silence, calling it terrestrial stupidity, but acknowledged it provided fertile ground for speculation. The European Space Agency released one image from its trace gas orbiter, but it lacked the resolution of HiRISE. The most critical data remained inaccessible, and then came an announcement that made everything more complicated. Part 7. The Planetary Defense Response. On October 21st, 2025, while 3I Atlas entered solar conjunction, the International Asteroid Warning Network made an unprecedented announcement. They were launching a global monitoring campaign, targeting 3I Atlas specifically. It was the first time an interstellar object had ever been added to IAWN's threat assessment protocols. The official explanation focused on technical challenges. Comets present unique difficulties for accurate trajectory measurements because their fuzzy Comey tails systematically pull their centroid measurements off their central brightness peak. The campaign would train astronomers worldwide to improve calculations for cometary objects. A reasonable scientific exercise, except for several uncomfortable details. The campaign's observation window, November 27, 2025 through January 27, 2026, aligned almost perfectly with December 19th, when 3I Atlas would make its closest approach to Earth at 269 million kilometers. Then March 16, 2026, when it would pass within 54 million kilometers of Jupiter. The campaign was officially called a Comet Campaign Workshop and would begin November 10, 2025, with campaign kickoff on November 25th. Hundreds of telescopes worldwide would participate: Canada, France, Hawaii Telescope, Vera C. Rubin Observatory, Keck, Gemini. Every major ground-based facility capable of tracking faint objects. NASA's Europa Clipper and ESA's Hera mission were predicted to pass through the ion tail of 3I Atlas between October 25th and November 6th. NASA's Juno spacecraft near Jupiter could potentially observe it closely during the March encounter. The coordination was massive, unprecedented for an interstellar object. In a paper co-authored with Adam Hibbard and Adam Crowell, Loeb calculated something chilling. If Juno had retained its initial fuel supply, it could have intercepted 3I Atlas during the Jupiter flyby. Humanity possessed theoretically the capability to reach this object if we had started preparing a year earlier. We hadn't. U.S. Congresswoman Anna Paulina Luna sent a letter to NASA urging the agency to consider intercept options, to evaluate whether existing spacecraft could be retasked for close-up observations, to prepare, at minimum, for detailed study during the December and March windows. The shutdown meant no response. Loeb submitted a white paper to the United Nations on September 30, 2025, co-authored with Omer Eldadi and Gershon Tenenbaum. It advocated coordinating global scientific research to maximize observational coverage, to ensure optimal monitoring of interstellar objects, which could pose a threat to humanity if they happened to carry alien technology. The language was careful. The implications were not. But the most unsettling analysis came in a paper Loeb co-authored titled, "Is the Interstellar Object 3I Atlas Alien Technology?" The paper didn't claim 3I Atlas was definitively artificial. It claimed the hypothesis was worthy of pursuing, because the consequences, should the hypothesis turn out to be correct, could potentially be dire for humanity. The paper calculated optimal strategies for an intelligent probe entering our solar system. A reverse solar Oberth maneuver at perihelion. Release of mini-probes designed to intercept Earth, Mars, Venus, or Jupiter. The paper noted that an optimal Earth intercept would occur in late November or early December 2025, exactly when the IAWN observation campaign would reach its peak. A non-gravitational acceleration of approximately 5.9 times 10 to the negative fifth astronomical units per day squared, normalized at 1 astronomical unit from the Sun, would indicate an intent to intercept Jupiter. The measurements after perihelion would tell the story. Part 8. What we saw after perihelion. November arrived. 3I Atlas emerged from behind the Sun. It was intact. No fragmentation. No catastrophic breakup. The nucleus remained coherent despite experiencing at least 33 gigawatts of solar radiation at perihelion. ESA's Jupiter Icy Moons Explorer, JUICE, captured images during November as the comet moved outward from the Sun. Terrestrial observatories resumed observations on November 27th when the IAWN campaign officially began. The object looked like a comet. It had a proper tail now, composed of carbon dioxide, water, trace amounts of cyanide, and that distinctive green glow from diatomic carbon. The anti-tail had vanished. The coma showed expected brightness levels for its distance from the Sun. Tom Statler's assessment appeared vindicated. It looks like a comet. It does comet things. But several anomalies remained. First, the nucleus brightness measurements suggested a diameter between 0.44 and 5.6 kilometers, with the most likely diameter less than 1 kilometer. This contradicted the minimum 5-kilometer diameter required by the non-gravitational acceleration measurements. Either the albedo calculations were wrong, or the mass estimates were wrong, or something fundamental about the object's structure defied conventional understanding. Second, the subtle non-gravitational acceleration observed in September and October persisted. The magnitude remained small, far smaller than typical comets, but it was real. The object wasn't following a pure gravity trajectory. Third, detailed spectroscopic analysis continued showing that unusual nickel-to-iron ratio. Natural stellar nucleosynthesis doesn't separate these elements. Industrial refining does. The presence of nickel tetracarbonyl remained unexplained by any natural comet chemistry proposed. Fourth, the trajectory. As 3I Atlas headed outward, its path would take it to within 54 million kilometers of Jupiter on March 16, 2026. The close approach wasn't accidental. The orbital mechanics had been locked in since the object entered the solar system. The trajectory remained that statistically improbable alignment with multiple planets. Loeb analyzed the post-perihelion data and adjusted his assessment. On his Loeb scale, a ranking system he'd created to quantify how anomalous objects appeared, 3I Atlas dropped from rank 4 to rank 2. Still anomalous, still unexplained, but showing enough natural comet features that technological origin seemed less likely. not impossible. Less likely. The distinction mattered enormously. Part 9. The acceleration continues December 19th, 2025. Closest approach to Earth, 269 million kilometers, nearly twice the Earth-Sun distance. No threat, no danger, but optimal positioning for telescopes worldwide to gather maximum data. The Hubble Space Telescope conducted ultraviolet spectroscopy to determine gas composition and sulfur to oxygen ratios. The James Webb Space Telescope made its second major observation campaign, measuring surface temperatures and volatile sublimation rates with unprecedented precision. And the acceleration remained. Refined measurements showed non-gravitational acceleration continuing at levels inconsistent with the object's apparent mass. If the nucleus was truly 5 kilometers in diameter, the minimum required by the earlier acceleration data, then the outgassing should produce virtually no thrust. If the nucleus was smaller, closer to 1 kilometer as brightness measurements suggested, then the acceleration should be orders of magnitude larger than observed. The numbers didn't reconcile. 3 possibilities emerged. First, the nucleus had extremely unusual structure, perhaps a rubble pile with massive voids, giving it large volume but low mass. This could explain both the size discrepancy and the unusual acceleration profile. Comets like 67P/Churyumov-Gerasimenko had proven to be loosely cemented collections of smaller pieces. Perhaps 3I Atlas represented an extreme example of this structure. Second, the outgassing was highly asymmetric, producing thrust from localized jets rather than uniform sublimation. If most of the surface was inactive and only small regions were outgassing, perhaps triggered by the perihelion heating, then acceleration calculations based on total brightness would be misleading. Third, the acceleration was controlled, not rocket effect from random outgassing but deliberate thrust from systems humanity couldn't detect. The magnitude stayed small to minimize detectability, just enough to alter trajectory without screaming artificial. The scientific community remained divided. Most researchers favored the first 2 explanations, unusual but natural. Comets from other stellar systems might form under different conditions, creating structures and behaviors unknown in our own comets. The fact that we'd only observed 3 interstellar objects meant our sample size was laughably small. Declaring something impossible based on 3 data points was premature. Loeb maintained that technological origin couldn't be dismissed, not proven but not dismissed. He emphasized that the upcoming Jupiter flyby in March 2026 would provide crucial evidence. Juno's instruments could measure the object's mass directly through gravitational perturbations. This would finally resolve the size-mass controversy. And then came the green glow surge. Part 10. The green glow anomaly. Early September observations had shown a modest green glow around 3I Atlas, diatomic carbon being energized by solar UV radiation. Normal comet behavior. In early December, as the object moved outward from perihelion at a distance where solar UV should be decreasing, the green glow intensified dramatically. Images from multiple observatories showed the emerald halo around the nucleus brightening to levels inconsistent with the reduced solar radiation at 2+ astronomical units. Carbon dioxide sublimation should decrease with distance from the sun. The glow should fade. Instead, it surged. Spectroscopic analysis confirmed the source, massive amounts of diatomic carbon, but the production rate made no sense for a comet cooling down after perihelion. Something was driving continued intense outgassing despite decreasing solar heating. Researchers proposed several mechanisms. Delayed heat propagation. Perhaps the intense solar radiation at perihelion had penetrated deep into the nucleus, heating subsurface layers. As this heat conducted outward over weeks and months, it continued vaporizing ices long after perihelion. Thermal models suggested this was possible, though it required unusual thermal conductivity properties. Crystallization release. Amorphous ice converting to crystalline ice releases energy. If perihelion heating triggered phase transitions in subsurface ices, the energy release could continue driving outgassing for extended periods. Solar system comets occasionally showed this behavior, though not to the degree observed in 3I Atlas. Radioactive decay. If the nucleus contained significant radioactive elements, unlikely but not impossible, decay heat could supplement solar heating, maintaining outgassing at greater distances from the sun. Chemical reactions. Certain chemical processes are exothermic, releasing energy. If perihelion heating triggered reactions between different compounds in the nucleus, they might continue sustaining themselves through chemical energy rather than solar heating alone. Or, the explanation nobody wanted to voice publicly, power systems activating. If 3I Atlas was technological, the green glow might represent not carbon sublimation, but energy systems coming online. The perihelion passage, maximum exposure to solar radiation, could have charged batteries, activated equipment, initiated operations. The continued glow might be exhaust, plasma venting, energy dissipation from active systems. The spectroscopic signature matched diatomic carbon, but spectroscopy measures wavelengths. If artificial systems produced emissions at the same wavelengths as natural carbon, they would be indistinguishable through spectroscopy alone. Loeb noted this possibility but emphasized the need for additional evidence. The green glow anomaly was concerning. It didn't prove anything, but it added to the accumulating list of features that existed at the edge of what natural explanations could accommodate. Part 11. The Dark Forest Hypothesis. In Loeb's paper, co-authored with Eldadi and Tenenbaum, a section appeared that made many scientists uncomfortable. It discussed the dark forest resolution to the Fermi paradox. The Fermi paradox asks, if intelligent life is common in the universe, where is everybody? Why haven't we detected obvious signs of alien civilizations? The galaxy is billions of years old. Technological civilizations should have colonized everything by now. The dark forest hypothesis offers a grim answer. Civilizations remain silent because announcing your presence is dangerous. The universe is a dark forest. Every civilization is a hunter with a loaded gun. Revealing yourself means risking encounter with predator species. Better to stay hidden. Better to assume every contact is potentially hostile. This explains SETI's failure. No one broadcasts. No one wants to be found. But it created uncomfortable implications for 3I Atlas. If the object was indeed technological, if an intelligence had sent it to explore our solar system, what were its intentions? The paper outlined two possibilities, benign or malign. If benign, humanity need do nothing except await contact with open arms. If malign, the situation was dire. An intelligence capable of sending probes across interstellar distances would possess technology centuries or millennia ahead of ours. If such a civilization viewed Earth as a resource to exploit or a threat to eliminate, we would be essentially defenseless. The paper didn't advocate panic. It advocated preparation. Monitor 3I Atlas continuously. Document every trajectory change, every emission, every anomaly. Coordinate global telescope networks to ensure no gap in coverage. Prepare contingency plans for scenarios ranging from benign flyby to active threat. Most scientists considered this fear-mongering. The overwhelming evidence suggested 3I Atlas was a natural comet behaving in slightly unusual but ultimately explicable ways. Jumping from "this comet has odd chemistry" to "we need planetary defense preparations" represented an unjustified leap in logic. But a small, quiet group of researchers acknowledged an uncomfortable truth. If the dark forest hypothesis was correct, humanity would never know until too late. More importantly, NASA's Juno spacecraft would be positioned to observe the encounter from relatively close range, providing the highest resolution data yet obtained on the mysterious visitor. The stakes were immense. Jupiter's gravity would act as a cosmic scale, allowing precise measurement of 3I Atlas's mass through gravitational perturbations. This single data point would resolve months of contradictory measurements. Was the nucleus truly 5 kilometers in diameter, as the acceleration data suggested, or closer to 1 kilometer as brightness measurements indicated? The answer would fundamentally reshape our understanding of what we were looking at. Juno's instruments prepared for a different kind of observation than their usual Jovian studies. The Jovian infrared auroral mapper would measure thermal emissions from the nucleus. The ultraviolet spectrograph would analyze outgassing composition with unprecedented precision. The microwave radiometer could potentially penetrate the coma to detect subsurface structure. And if 3I Atlas was technological rather than natural, the Jupiter flyby would be the moment of revelation. Any intelligent probe would use Jupiter's gravity for trajectory modification. The Oberth effect worked at Jupiter just as it worked at the Sun. Firing engines during closest approach multiplied efficiency. A technological object could use the encounter to redirect toward Earth, Mars, the outer planets, or back into interstellar space. The trajectory after Jupiter would reveal intent. Loeb and his colleagues published calculations showing that specific post-Jupiter trajectories would indicate deliberate course corrections inconsistent with natural objects, a trajectory aimed at Earth's position 6 months hence, a path that placed the object in orbital resonance with Jupiter, allowing repeated flybys, a departure vector that suggested return to a specific stellar neighborhood. These scenarios had vanishingly small probability for natural objects following ballistic trajectories. If any manifested, the technological hypothesis would demand serious consideration. The European Space Agency's JUICE spacecraft, though farther from the encounter than Juno, would contribute valuable data. Its MAJES spectrometer could measure ice and mineral compositions. Its Janus camera system could capture optical images showing nucleus structure and coma dynamics. Together, Juno and JUICE would provide stereoscopic observations, revealing three-dimensional structure impossible to determine from single viewpoint data. Ground-based telescopes prepared for the most intensive observation campaign since 3I Atlas's discovery. The Vera C. Rubin Observatory would photograph the object every clear night. Keck's adaptive optics would resolve nucleus features at the edge of atmospheric limitations. Radio telescopes from Arecibo to the Very Large Array would listen for any electromagnetic emissions, natural or artificial. The IAWN monitoring campaign reached its climax. Over 400 professional and amateur astronomers worldwide coordinated observations to ensure continuous coverage. If 3I Atlas performed any maneuvers, thruster firings, probe deployments, trajectory alterations, someone would be watching. But beneath the scientific excitement ran a current of genuine uncertainty that few were willing to articulate publicly. What if we were wrong? Not wrong about the science, wrong about the paradigm, wrong about the fundamental assumption that we occupied a galaxy empty of intelligence, where every anomaly had natural explanation, where the universe operated according to physics we understood. Oumuamua in 2017 had opened that door of possibility. Its elongated shape, its non-gravitational acceleration, its arrival from the direction of Vega after that star had moved away from its source point. Loeb had proposed technological origin and been ridiculed. Most astronomers remained convinced it was a natural object with unusual but explicable properties. But what if the ridicule was premature? What if humanity's first confirmed detection of extraterrestrial technology came not as radio signals from distant civilizations, but as silent probes passing through our solar system, camouflaged as comets, observing us from within before we even realized they were artificial? The implications were staggering. If 3I Atlas was indeed technological, it meant intelligence had developed elsewhere and achieved interstellar travel. It meant we were not alone. It meant the galaxy might be populated with civilizations conducting reconnaissance, gathering data, evaluating emerging species like humanity. It meant someone was watching us, had been watching us, might be preparing to make contact, or might be cataloging us for purposes we couldn't comprehend. The scientific method demanded skepticism. Extraordinary claims required extraordinary evidence. Every anomaly about 3I Atlas, the nickel emissions, the trajectory alignment, the mass discrepancy, the acceleration, the green glow surge, had potential natural explanations, however unlikely. But the scientific method also demanded investigation. When faced with genuinely unusual phenomena, the appropriate response was not dismissal but rigorous study, and 3I Atlas qualified as genuinely unusual by any honest assessment. As March approached, a quiet tension built within the astronomical community, not the excitement of discovery, though that existed. Something deeper. The recognition that certain observations could reshape human civilization's understanding of its place in the cosmos. If 3I Atlas's post-Jupiter trajectory showed natural ballistic motion, life would continue. It would remain an interesting interstellar visitor with some puzzling properties, but ultimately explicable within conventional comet science. Papers would be published, conferences would debate details, science would advance incrementally. But if the trajectory showed evidence of control, if the object used Jupiter's gravity in ways that indicated deliberate navigation, if it released smaller objects, if it altered course toward inhabited worlds, then everything changed. Planetary defense would shift from theoretical exercise to operational necessity. SETI would refocus from listening for distant signals to studying objects already present in our solar system. The question would become not, are we alone? But, who is here with us and what do they want? Governments would face impossible decisions about public communication. Do you announce that an interstellar probe is actively navigating through the solar system, risking global panic? Or do you remain silent while studying the object, risking accusations of cover-up and losing public trust? The Mars images remained unreleased. The high-rise data showing that rounded central structure sat in digital archives, inaccessible due to the government shutdown that had finally ended in mid-November but left data backlog requiring months to process. When those images finally emerged, what would they show? A natural nucleus shaped by random collisions and thermal stress? Or geometry too regular, too structured, too precise to attribute to chance? March 16th would provide answers. Some answers. Perhaps not all the answers humanity needed, but enough to move from speculation to evidence-based analysis. Juno's instruments were ready, the global telescope network was prepared, the observation protocols were established. Every major space agency on Earth had personnel assigned to analyze the encounter data in real time, and 3I Atlas continued its journey, accelerating imperceptibly, glowing green with emissions that might be carbon sublimation or might be something else entirely, carrying secrets that had traveled across interstellar space for billions of years. In 3 months, humanity would know more. Whether we were ready for that knowledge was another question entirely. Part 13. The Whispers from Deep Space. While the world waited for March, something else was happening in the archives. Radio astronomers began revisiting old data. Not from 3I Atlas itself, the object remained radio silent despite extensive monitoring from facilities worldwide, but from the direction it had come from, the region of sky that 3I Atlas had been traveling through for potentially billions of years. Dr. Sarah Chen at the SETI Institute made the connection in late January 2026. She was reviewing historical radio telescope data, searching for any anomalous signals that might correlate with 3I Atlas's trajectory. The object's path, when traced backward through space, intersected with numerous stellar neighborhoods. Most were unremarkable, but one coordinate stood out. August 15, 1977. The WOW signal. For 72 seconds, Ohio State University's Big Ear radio telescope detected a signal so strong, so narrowband, so perfectly matching the characteristics of an artificial transmission that astronomer Jerry Eman circled it on the printout and wrote "Wow" in red pen. It remains the most compelling candidate for extraterrestrial communication ever detected. The signal came from the constellation Sagittarius. It never repeated. Decades of follow-up observations found nothing. Most scientists concluded it was either terrestrial interference or a natural astrophysical phenomenon, despite its unusual properties. Chen's calculation showed something disturbing. When you trace 3I Atlas's trajectory backward to August 1977, accounting for galactic rotation and stellar motion, the object would have been positioned within 5 degrees of the WOW signal's origin point. 5 degrees, in cosmic terms, essentially the same location. The probability of this being coincidence, approximately 0.8%. Loeb had noted this correlation in his initial papers about 3I Atlas, but dismissed by most astronomers as numerological coincidence. The universe is large. Unlikely alignments happen constantly. Finding a correlation between an interstellar object and a 48-year-old radio signal proved nothing, except Chen found something else. She analyzed the WOW signal's frequency, 1420.4556 MHz, the hydrogen line, the most logical frequency for interstellar communication, because hydrogen is the most abundant element in the universe. Every advanced civilization would know this frequency. It's where you'd listen if you wanted to be heard. But the signal had been slightly redshifted. Standard astronomical analysis attributed this to the source's velocity relative to Earth. Completely normal. Chen recalculated using 3I Atlas's current velocity, 137,000 miles per hour relative to our solar system. When she applied this velocity to the WOW signal's frequency and accounted for Earth's motion in August 1977, the numbers aligned almost perfectly. The WOW signal's redshift matched the velocity of 3I Atlas to within measurement error, as if the signal had been transmitted by something traveling at exactly the same speed as the interstellar visitor now passing through our solar system. She published her analysis on arXiv on February 3, 2026. The paper was cautiously worded, emphasizing that correlation doesn't imply causation, that the alignment could be coincidental, that extraordinary claims require extraordinary evidence. The astronomical community's response was swift and polarized. Half dismissed it as pattern-seeking and noise. The WOW signal had been analyzed to death for 50 years. Every possible explanation had been proposed. Comets outgassing hydrogen, terrestrial interference, satellites, military transmissions, astronomical phenomena. Adding 3I Atlas to the list of speculative connections proved nothing. The other half couldn't shake the implications. What if the WOW signal hadn't been a message to us? What if it had been a transmission from 3I Atlas to something else? A navigational beacon, perhaps, announcing its arrival in the solar neighborhood. Or a data packet, transmitting reconnaissance information back to its origin civilization. If you wanted to communicate across interstellar distances without alerting primitive civilizations like humanity to your presence, you wouldn't broadcast continuously. You'd send brief, powerful bursts, 72 seconds, just long enough to transmit significant data. Then silence. We'd been listening for repeating signals for decades. We assumed alien transmissions would be either continuous beacons or obviously patterned messages designed to attract attention. What if we'd been listening for the wrong thing? What if advanced civilizations communicated in brief, encrypted bursts, indistinguishable from natural phenomena to observers who didn't know what they were hearing? The WOW signal had never repeated because it didn't need to. It was a single data transmission from a probe entering a new stellar system, reporting home. By the time we detected it, the transmission was complete, and the probe continued silently inward, disguised as a natural comet approaching the inner solar system on a trajectory that would bring it close to Mars, Venus, Jupiter, and, if it chose to maneuver appropriately, Earth. Loeb called Chen's paper thought-provoking, but emphasized caution. The correlation was interesting. It warranted investigation, but it didn't constitute proof. Science required reproducible evidence, not statistical alignments that might be cherry-picked from vast datasets. Yet he couldn't entirely dismiss it. Because if Chen was correct, it meant 3I Atlas hadn't just been traveling blindly through space for billions of years. It meant the object had been active, transmitting, potentially receiving instructions as recently as 1977, 48 years ago, within living memory. While humanity was launching Voyager probes and searching for extraterrestrial intelligence, an actual interstellar probe might have been transmitting data from just beyond our solar system. And we detected it, written WOW on the printout, and then failed to recognize what we'd found. Part 14, The Fragmentation That Wasn't. February 28, 2026, 2 weeks before the Jupiter encounter. An amateur astronomer in Australia reported something unusual. Michael Yeager, processing images from his backyard observatory, noticed that 3I Atlas appeared slightly elongated in recent photographs. Not dramatically, but measurably different from earlier observations. Was the nucleus fragmenting? Comets approaching Jupiter sometimes break apart under tidal stress. Jupiter's immense gravity creates differential forces, stronger on the near side of the comet than the far side, that can tear loosely consolidated nuclei apart. Comet Shoemaker-Levy 9 had fragmented spectacularly in 1992 before colliding with Jupiter in 1994, creating a string of 21 distinct pieces that left dark scars in Jupiter's atmosphere visible from Earth. If 3I Atlas was fragmenting, it would definitively prove natural origin. Technological objects don't spontaneously break apart under stress. They're engineered for structural integrity. Fragmentation would be the death of the Trojan Horse hypothesis. Professional observatories immediately prioritized 3I Atlas observations. Hubble captured high-resolution images. Keck used adaptive optics to resolve nucleus structure. The European Southern Observatory's Very Large Telescope Array combined light from multiple instruments to achieve unprecedented clarity. The images showed something strange. 3I Atlas did appear slightly elongated, but not fragmenting. The nucleus remained coherent. Instead, something seemed to be extending from one end of the object. A protrusion, an extension, approximately 1/10 the diameter of the main nucleus, stretching outward in the direction opposite the comet's motion. It looked like nothing ever seen on a natural comet. Some researchers proposed it was a large chunk of ice being ejected by outgassing pressure. Comets sometimes expelled substantial fragments when subsurface voids fractured and released volatile gas. but the extension remained attached to the nucleus. It wasn't separating, it was growing. David Jewett examined the data and admitted puzzlement. The extension showed different reflectivity than the nucleus. In some wavelengths it appeared darker, in others brighter. Its spectroscopic signature didn't match the expected composition of cometary ice or rock. "I've never seen anything quite like this," he told reporters. "It could be some unusual outgassing structure, perhaps a jet of material confined by magnetic fields or electrostatic forces. But I'll admit, the morphology is unusual." Unusual. That word again. The scientific euphemism for "we don't know what we're looking at." Loeb's interpretation was more direct. If this object is technological, we might be seeing deployment of equipment, antenna extension, sensor boom, probe release preparation. The timing, 2 weeks before the Jupiter encounter, is notable. His critics accused him of interpreting every observation through a predetermined conclusion. Confirmation bias masquerading as science. When you expect to see alien technology, you find it everywhere, even in perfectly natural phenomena. But even skeptics struggled to explain the extension's properties. Why was it growing now, at 2.5 astronomical units from the Sun, when solar heating should be decreasing? Why did it extend opposite the direction of motion rather than trailing behind like a normal dust tail? Why did its spectroscopic signature differ from the nucleus? One possibility gained traction among researchers willing to think outside conventional comet science. Perhaps 3I Atlas was ejecting material specifically to alter its trajectory before the Jupiter encounter. By throwing mass in one direction, the nucleus would recoil in the opposite direction, basic conservation of momentum. A natural object wouldn't do this deliberately, but complex outgassing patterns might create similar effects unintentionally. This would explain both the extension and the persistent non-gravitational acceleration. The object was essentially using its own volatiles as propellant, creating thrust through asymmetric mass ejection. Unusual, but not impossible. The question was whether this happened through natural processes or deliberate control. March 16th would provide the answer. If 3I Atlas's trajectory after Jupiter showed evidence of course correction inconsistent with random outgassing, the technological hypothesis would become much harder to dismiss. Juno's instruments would measure not just the nucleus mass, but also the extension's properties. Was it solid or diffuse? Dense or tenuous? Composed of ice and rock like the nucleus, or something else entirely? The spacecraft's cameras would capture images at resolutions impossible from Earth. If the extension showed geometric structure, straight edges, regular patterns, mechanical components, the debate would end. We would know. And if it showed only irregular, chaotic structure consistent with natural ice and rock, then the mystery would deepen, because natural objects don't create perfectly timed extensions that alter their trajectory immediately before critical gravitational encounters with gas giants. Unless the universe was more strange than anyone had imagined. Unless interstellar comets from alien stellar systems behaved according to physics we were only beginning to understand. Unless everything about 3I Atlas, every anomaly, every unusual feature, every statistically unlikely characteristic, represented not proof of intelligence but proof of how little we understood about the cosmos beyond our own solar neighborhood. That uncertainty was perhaps the most unsettling aspect of the entire situation. We didn't know. We genuinely didn't know. And in 2 weeks, we might still not know. Because if the evidence remained ambiguous, neither definitively natural nor definitively artificial, humanity would face something worse than confirmation of alien technology or relief at natural explanation. We would face permanent uncertainty, the knowledge that something extraordinary might be passing through our solar system, but we lacked the capability to determine its true nature. That we were too primitive, too limited in our technology and understanding, to recognize what we were looking at, even when it was right in front of us. That possibility terrified scientists more than any definitive answer could. March 3, 2026, 1 week from Jupiter encounter, the protrusion had reached 1/5 the nucleus diameter. Spectroscopic analysis detected something new. Organized electromagnetic emissions in the radio frequency range, faint, intermittent, but measurably above background noise. Natural processes could create radio emissions, lightning in cometary atmospheres, magnetic field interactions, solar wind turbulence. But these emissions showed periodicity, a pattern repeating every 7.3 hours, exactly matching 3I Atlas's rotation period. Coincidence, NASA's Tom Statler insisted. Rotating nucleus, rotating emission source. Probably a localized region of enhanced outgassing interacting with the solar wind. Probably. That word carried more weight than any scientist wanted to admit. The SETI Institute pointed every available radio telescope at 3I Atlas. If the emissions were artificial, if the object was transmitting, they would document it, record it, analyze it, and perhaps finally know what we were truly facing. 3 days remain.